Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 9 from the Pure Mathematics P3 paper from June 2023. And here we have a question, part A, which is about trig identities, which is one of the topics where some students have issues where, because they can't see the whole journey from the beginning of the question, they feel a bit lost and don't really start the journey in the first place. But you got to take a few steps in the dark sometimes. All right, so here we have to show that this expression here, cosine 2x over sine x plus sine 2x over cosine x, will become the same as cosecant of x. All right, so the first thing that we can see here very clearly is that we have double angles, okay? And the answer is only in terms of single angles. That's one thing that we can see. So it might be a good idea first to try to rewrite these in terms of single angles, okay? Now for sine 2x, we don't really have any choice. Sine 2x, as we should know, is equal to 2 sine x cosine x. This is not given in the formula sheet. However, what is given in the formula sheet is the sine of a plus b equals the sine of a times the cosine of b plus the cosine of a times the sine of b. And if we make them both the same, like if we make them both x, you have sine x plus x, which is the same as sine 2x. Then that will give us the sine of x times the cosine of x plus another cosine of x times the sine of x, which gives us basically 2 sine x cosine x. That's where that comes from. All right, so if you forget this, you can easily use the formula sheet and make this into sine 2x by calling it sine x plus x, and then you can derive this formula. And similarly with cosine 2x, we can do a very similar thing. So I'm just going to use the same space again. So we can say that the cosine of 2x is the same as cosine x plus x. And in the formula sheet, you'll see the formula cosine a, and it has plus minus b, equals the cosine of a times the cosine of b minus plus the sine of a times the sine of b. That's what the formula sheet gives us. So the cosine of x plus x will be the cosine of x times the cosine of x, which would be cosine squared x, and is a plus, so there's going to be a minus between them in this case. And then you have the sine of x times the sine of x, which would be the sine squared of x. Now from this, we can go two ways. We can write everything in terms of cosine squared x, or we can write everything in terms of sine squared x. If we want to write things in terms of sine squared x, then we can replace this with 1 minus sine squared x, and we've got another minus sine squared x, so that gives you 1 minus 2 sine squared x. However, if you want to write things in terms of cosine squared x, then we can write this as cosine squared x minus, in brackets, 1 minus cosine squared x. We're using the fact that cosine squared x is 1 minus sine squared x, and sine squared x is 1 minus cosine squared x, because sine squared x plus cosine squared x equals 1, which, as we should know. So this is going to give you cosine squared x minus 1 plus cosine squared x. So that's going to give you 2 cosine squared x minus 1. So cosine of 2x has two forms that we can write it in. We can write it as 1 minus 2 sine squared x, or we can write it as 2 cosine squared x minus 1. Okay, so that's how we can change these double into single angles. Now, as I said, for this one, we have no choice. So I'm going to write this as, this will be cosine x in the denominator, and this will be 2 sine x cosine x. And here we got over sine x. Okay, and we can rewrite this in either one of these two ways. Now we got to think of the way that's going to help us to solve this problem. Okay, what way can we write it to help us to solve this problem? Okay, can we write it as 1 minus 2 sine squared x, or should we write it as 2 cosine squared x minus 1? Okay, how is that going to help us? We have to end up with cosec x. Remember, cosec x is 1 over sine x. So we have to end up with sine x in the denominator. In this case, you won't have a denominator for this particular part. But this part here, if you want to end up with sine x in the denominator, okay, and we have sine x here, I suggest we write this as 1 minus 2 sine squared x and see how that helps us. Let's see how that helps us. So now the next step we can write is basically, let's combine these as one fraction. So if you combine these as one fraction, you have a common denominator of sine x. And this is 1 minus 2 sine squared x. And here we're going to have plus. Now I have to multiply this by sine x to make it into sine x denominator. And I have to multiply this also by sine x. What you notice is going to become plus 2 sine squared x. And the next step, we got the answer. We have 1 over sine x, because these two they cancel out, which is equal to cosecant x. Okay, so there's the answer to that question. Pretty simple. Now, we could have done it another way. So this is like one alternative. I'll show you a couple of different alternatives just to show that it doesn't really matter. As long as you do the right thing, you're fine. So for example, we could have started off by saying this 2 terms has become 1 term. So let's start off by adding these 2 fractions together. So we make a common denominator, which is sine x times cosine x. Okay, so I have to multiply this by cosine x. So I have cosine x times cosine of 2x plus, and I have to multiply this by sine x. That's going to be sine x times sine of 2x. So now we've made them into one fraction. All right. So now we're going to try to deal with it. So we have to be left with sine x in the denominator. Okay. So let's think how we can now, change these double angles into single angles. So we have cosine x times. Now what we could do here is we could write this as plus, let me see, yeah, here you have sine x times, let me just set it up a bit first, times, and you're going to have to write this in this one has no choice. This will be 2 sine x cosine x. That one, there's no choice about that sine 2. That's going to give you something like this. That will be 2 sine squared x cosine x. Now for this one, we have a cosine x on the outside. Okay, this is all over sine x cosine x, by the way. Okay, so we want in the end, all right, what do we want to happen? We want the cosine x to be cancelled out, right? Well, the cosine x to be cancelled out. So I'm going to write this as 1 minus 2 sine squared x. And then when I expand, you'll see what happens. I think the first way I did it is way easier, but this is just an alternative. So we have cosine x times 1 times 2 times sine squared x times cosine x plus, and you got 2 times sine squared x times cosine x. Okay, so you end up with, so it works out quite nicely as well. See, once you've expanded, you can see what's going to happen next, because you got minus 2 sine squared x cosine x and plus 2 sine squared x cosine x. They cancel out, and we're left with cosine x over sine x times cosine x. They cancel out. You're left with 1 over sine x, which is what we had to show is cosecant x. Okay, so that's sorted out that question. All right, so that's basically how you can deal with that. Now, if you had written this as 2 cosine squared x minus 1, then it wouldn't have kind of worked out. You wouldn't be able to. So you could have gone back here. So let's try 1 minus 2 sine squared x. And then you see it does work out. So sometimes you might have to, here we weren't quite sure what to use, right? But we went with 1 minus 2 sine squared x. If I went with 2 cosine squared x minus 1, and I found that it didn't work out, that it didn't simplify very easily, then we could go back to square one, just change this to 1 minus 2 sine squared x and try that, and you see what happens. They cancel out. Okay, it's possible also when you put 2 cosine squared x minus 1, it still also works out. Okay, it doesn't seem that it would here, but it could still work out in some way, and you end up with the answer. But I think the simplest way was the way I did first. I started off by changing all of these double angles into single angles, because that's what I saw. Our answer has to have a single angle. And then it worked out very easily. All right, so there's the answer to question 9, part A. Okay, so now 9 part B. Okay, it says, hence solve for theta between 0 and pi over 2 this equation. Okay, so let me just get the result from before. Okay, so now we have the result from the previous, part A. Okay, so we have, if you notice here, this is cosine 2 theta over sine theta, sine 2 theta over cosine. So this is basically the same thing, except the theta has become, or the theta is now the x. Or you can say the x has become the theta. The theta is the x in the old part of the question. That's all. So I can say, therefore, that this is equal to cosec theta. So I can say cosec theta all squared equals 6 cot theta minus 4. So this gives us, remember that's the same as saying cosec squared theta equals 6 cot theta minus 4. Now, there's two ways we can proceed from this question. One way is to use the identities involving the reciprocal trig functions and then, rewriting them so that you can solve it. The other way is to change them into what's familiar, change this into 1 over sine squared theta and this into cosine theta over sine theta. I personally think that's going to be more hassle. So what I'm going to do is I'm going to rewrite this in terms of cot theta. Now we know, if you forget your trig identities, the reciprocal ones, we know the basic one is sine squared theta plus cosine squared theta is equal to 1. And if I want to end up with something which involves cosec squared theta, then I have to divide by sine squared theta. That gives me cosec squared theta. That's what I'm looking for. What is cosec squared theta equal to? Well, I have to divide everything by sine squared theta. Okay, so I end up with 1 plus, now cosine over sine is cot, so that's cot squared theta. So I can replace this with 1 plus cot squared theta equals 6 cot theta minus 4. The one that is squared is the one that you try to replace, because we know that this is true for 1 plus cot squared theta equals cosec squared theta. You can't say 1 plus cot theta equals cosec theta. No. 1 plus cot squared theta is equal to cosec squared theta. Okay, so cosec squared theta can be replaced by 1 plus cot squared theta. Now we have a quadratic equation on our hands. So I can rearrange it. I'll say cot squared theta minus 6 times cot theta, and you're going to have 1 plus 4, which is plus 5, is equal to 0. So let's say let cot theta equals u. So this is going to be u squared minus 6u plus 5 equals 0. So two numbers multiplied to give you 5, and they both have the same sign, and they add to give you minus 6. Well, that's pretty easy. It's u minus 5 and u minus 1. When I multiply them together, I get plus 5. When I add them, I get minus 6. So that will give us our answer. So u is going to be 5 and u is going to be 1. So we can say that cot of theta is equal to 5 and the cot of theta is equal to 1. Right, so now, if the cot of theta equals 5, that means the tangent of theta is equal to the reciprocal of 5, which is 1 over 5. The reciprocal of cot theta is tan theta. The reciprocal of 5 is 1 over 5. And if cot theta equals 1, then tan theta must also equal 1. Right, so for this, there's no problem. Theta is going to be pi over 4. Okay, theta is going to be pi over 4, which is within our range between 0 and pi over 2. Okay, it says give your answer 3SF as appropriate. Well, this one is not really appropriate for 3SF. It's an exact value, so you can leave that as it is. But this one, theta equals inverse tan of 1/5. This is going to be something which I think we will have to write to 3SF. So let's take our calculator, make sure that we are in radian mode, inverse tan of 1/5. And that gives us 0.19739. So theta equals 0.19739 radians to 3SF. Theta equals 0.197. Okay, so there's the answer. Theta equals 0.197 and theta equals pi over 4. Okay, those are both within the range. Okay, because the range is up to pi over 2, and we know that pi is 3.14. So pi over 2 is going to be 1 point something, 1.5 something. So we're definitely in the range of the answer. And there's no other solution going to be there because the other solution, you have to add pi to this to get to it. And of course, that will be outside of our range. All right, so there's the answer. Similar thing for this. The other solution will be outside of the range because our range is so small. Okay, if you add pi to this, you're outside of the range. Okay, so that completes question number 9, part B. Okay, solving this trig equation using the result that we had from before and these disguised quadratics. Okay, as I said, some people are more comfortable at this stage of writing this as 1 over sine squared theta and this is sine theta over cosine theta and then rearranging it and solving it. And that's fine if you like that. I personally prefer to just go with the reciprocal trig ratios, and that's fine. Okay, so now for part C, 9C. It says, using the result from part A or otherwise, find the exact value of this integral. Now, by far, okay, using the result from part A, or sometimes this whole phrase here can be just replaced with hence. Okay, so using the part A result or otherwise, find the exact value of this integral. Okay, so now what we see is all of this can be replaced by cosec x. So we can say, remember, it's only worth 2 marks. It's not a really huge question. Okay, so it doesn't involve many steps. And once we've actually replaced this by cosec x, we should be able to see the answer. So you have cosec x times cot x dx. Okay, now we should recognize this as one of our standard integrals. Okay, if you're not sure about that, you can just go straight to the formula sheet, which I have here, and you can see. Now, if you don't find it under the integration part, you'll definitely find it in the differentiation part. You're going this way. So we can see cosec x, cot x is the result of differentiating cosec x. That means the integral of cosec x, cot x must be equal to minus cosec x plus c, because there's a minus here, right? So the integral of cosec x cot x is equal to minus cosec x plus c. You'll notice that the integrals and the differentials of things which are, starting with co, all right, if you integrate anything starting with co, you end up with a negative differential. Okay, so even cosine x becomes minus sine x when you integrate it, and cosec squared x becomes minus cot x, and minus cosec x cot x becomes minus cosec x. All right, so this is basically the result that we're going to use. We can just replace it by minus cosec. We can just write it, the integral of this is equal to minus cosec x plus c. In this case, we don't need the plus c because we have a definite integral. So we can just say this is going to be equal to, I'll put the minus on the outside, cosec x. The integral of cosec x cot x is cosec x, minus cosec x. So I'll write the minus on the outside. I've got pi over 4 and pi over 6. So remember, this is the same as 1 over sine x. So you got minus, and this is 1 over sine x between pi over 4 and pi over 6. And we want the exact value. So 1 over the sine of pi over 4. Okay, and you're going to have minus 1 over the sine of pi over 6. Right, the sine of pi over 4 is root 2 over 2. Root 2 over 2. Okay, which is the same as saying 1 over root 2. Okay, so in fact, I'll write it as 1 over root 2 because you're going to have 1 over root 2, which is going to give you root 2. And you got minus here. Pi over 6 is the same as 30 degrees, so that's going to be 1 over a half. Okay, so we can see here, you'll end up with, this is going to become minus, you're going to have root 2 minus 2, so you end up with 2 minus root 2. Okay, because the reciprocal of 1 over root 2 is root 2, the reciprocal of a half is 2, minus will change the sign of the root 2, and the negative 2, 2 minus root 2 is the exact value of the integral of this. And there we have the answer, 2 minus root 2. And that concludes question number 9 from this paper, okay, on P3 of June 2023. Other questions from this particular paper can be found in the playlist that will appear over here. You can find questions involving trig identities equations in this playlist over here. The last part of this question is to do with integration of trig functions, which you can find in the playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.